First, hi, thanks for clicking on my video. I have an actual script, so I'm going to be looking at it from time to time. Don't mind me. Getting right to it, I have worked on understanding the Moai 130, its menu, its settings, and changing each one until I got the results that I wanted. With many of the benefits of the Moai SLA system over the price of competitive MSLA systems, it would help any Moai owner if your printer printed mechanically accurate. For most Moai owners, this has been a lost gold, and it was used for organic shapes, which it does really well. Unfortunately, as it prints well and reliably, the mechanical angle has always been the holy grail for Moai users. Let's go over what I figured out and get your Moai to print mechanically accurately. And we'll do it from scratch. Hop in, it'll be a bit of an instructional video, and let's get right to it. Part 1, plate calibration. The first thing we must do is orient the laser to be as centered on the plate as possible. The provided cross calibration sheet isn't enough on the PDMS because it has no point of calibration. The FEP provides this in spades. Using the FEP vat and the easy level build plate, loosen all the easy level screws and set your Z reset position. First, change it by 2 points, click once, and then set it back to your Z reset position. And double click on the selecting knob. That will cause it to lower into position. Once the build plate is in place, move it around until it is set between the acrylic holes in the FEP. Once it is there, tighten all 4 bolts in cross section. Top left, bottom right, bottom left, top right. Normally, that would be done every time you change your vat. My printer had a unique error. I had to create a spacer on the outside edge, so my build plate was centered. It's still not perfectly centered, but the FEP vat is about 130 by 125 millimeters of usable volume, where the build plate itself is 130 by 130 millimeters. Once the build plate is centered onto the FEP vat, we have a relative center of our print area. The laser and the galvos are suspended on pressure clamps, each held by a single Allen key nut. Loosening it will allow them to slide about and be positioned easily. It's very easy to do. So easy, in fact, that I have given you all the instruction you need. Cut the cross calibration sheet and put it to the same position that your plate rests in the FEP vat. When loosening the bolts on the galvos, twist them until that laser aligns with the cross point on the cross calibration sheet. Once the X and Y galvo are calibrated, you're ready to go. We're going to be working with these 100 by 100 millimeter cross forms printed on your Moai to start the calibration. You can blow the calibration out far enough to where you print warped shapes. You're also going to need a single pair of digital calipers. The provided cross file should take about 40 minutes of print time to get this finished. I made the file in Mexmesher. It's a 5 millimeter tall, 2 millimeter wide, 100 by 100 millimeter beams, or just blocks that I rotated 90 degrees on themselves, and then exported into the slicer. Very easy. So when you start printing these, you should print at least 5 of them in your system. That way you get a good variation. Now, there has been some instances where your laser is so high, you're going to get bleed over effect, and all prints are going to be larger. So you can lower your laser value. Start off by generating the average value of all your measurements. The more you do, the more accurate your baseline is. Though I think 5 is plenty, as you get diminishing returns by doing too many. There are two settings in the system we're going to work off of, corresponding to the section size X and size Y. Cool. Both of these are defaulted in the system to 900. In the first page of settings, it's the very top two settings. Very quick, very easy to get to. Changing those will change your dimensionality on both the X and Y axis. To get what you need them set as, use this formula. This deviation, or this permanent value, well, this value, this default value, divided by the average result of your 5 or so prints. Mine came out to be like 98, so 900 divided by 98. That gets your deviation. That deviation value is then multiplied by the intended result, which is 100. We know that because of the slicer and mesh mixer. So that deviation times 100 should be the value this is to be set in. And if you've got good eyes and you're squinting in right now to see what I've got it set at, I've got it set at 907 and 916. If you do quick math in your head, you could realize that 1 point on this is basically 1.1 or 0.11 millimeter of deviation. So if you're doing this by the math and you wind up with a 99 like I did and you want it to move down, you need to move it up or down about 9 points. That'll get you to where you need to be. Me, I just did it the mathematical way. That shows me where I should be, and then I could fine tune this as time goes on. So that is the setting as it is now, and as I do more prints to verify dimensionality, that will change slightly. But that is my starting point, and that is the most important feature of this entire video. When you change the X and Y value in your machine and you want to test again, you have to completely power cycle the machine. Once you change it to whatever value, you click that knob, double click it to go back into the menu, turn off your machine. If you don't do this step, these settings will not take. When you turn it back on, go back to your setup and verify that the setting took. If it didn't take, make sure you double click when exiting. Make sure you single click before double clicking when exiting. Yes. If it did not take, make sure you single click before double clicking. Ah, yes. With those new firmware settings in place, give you cross calibration another print. You should be drastically closer to 100 millimeters than you were before. There is some deviation and you may be a little over or under. It'll take a few more test prints, so don't worry about it. Just change it as you go along. You will probably have to do that with every firmware update that comes out. Everyone. You never know what they change in the back end, so it's best just to go ahead and do it. Z calibration. Okay, unlike the X and Y settings, there is no firmware setting for the Z calibration, which is unfortunate because every printer that uses a stepper motor has a stepper value that lets it know how many steps it takes to make real world measurable values. So if it moves 100 millimeters via steps, you should measure 100 millimeters as a result. If it doesn't, that means the steps are off and they have to be adjusted. Unfortunately for us, Moai has not released that in the settings calibration. So if we get a deviation, which for mine it's 1%, and if we get a deviation, there's no way to permanently change that in the firmware to get consistent results, and we have to do that in the slicer. The Z-axis on my Moai is the upgraded one. The position that you measure may change slightly on your printer based on the fact that you may have the default linear rail, but there should be a spot in there that you can measure to. For me, it was simply the top of the mounting bracket. First, power cycle the printer. Once the support arm has risen to its default position, take a measurement of the first position. On my printer, this was 270 millimeters exactly. With the build plate removed, go into the firmware and change the Z reset position to 1800. Double-click the knob and let the arm go to this position. The result of my printer was 88 millimeters. The math states that 270 minus 88 is 182. The way the Moai is set up, 1800 is set at 180 millimeters, and the distance should read 180 millimeters traveled. Dividing the distance it should have traveled by the distance it traveled, we get the percentage of error. The stepper motor steps should be changed to this value. My printer, it's 98.9. And if I knew the stepper value, which should be, my knowledge on FDM printers, it should be anywhere between 400 to 200. That's usually the step count for measurement calibration. I would change that to 98.9% of its current value. Same thing I did with the X and Y deviation. In fact, it's all the same concept. Until this is opened up in the firmware, you have to do it in the slicer. For that, we have to go to the computer. I use Cura, and I am very thankful to Poly for making this work in any slicer. It's the reason I chose the Moai over other less expensive printers. When you have a model in your slicer, you need to use the scale utility. This will change the size of your model. Cura allows you to adjust the exact measurement and a percentage of the result. Uncheck uniform scaling so we can adjust one dimension at a time. If you depend on your slicer to change the scale of the model, I would suggest using a mesh mixer so you can also inspect, orient, or slice the model as needed. Changing the Z-axis to the percentage result will be our best practice. This will compensate the stepper calibration on your print. On some models, the adjustment is so small the print deviation would be larger. For mechanically accurate prints, you would do it for every model, no matter its size. Moving on. And now for Cura settings. With all three axes, with all three dimensions calibrated, we can start printing dimensionally accurate prints. However, there's still a few things in Cura we really need to go over. We will adjust a few elements for maximum print quality. There isn't a lot here, so this will be simple. First, in your quality section, we have a line width value. This is defaulted to 0.067. Moai states, or in some of their documentation, they have stated it is 0.07. If you print the circlet file, this is uncured by the way, if you print the circlet file, you may get spots that don't adhere, they're stringy, or it seems like they didn't touch the walls and are just peeling off. That value will help compensate that. Of course, there is another menu setting in here. Under Advanced Calibrations, there's Compensate X and Y. Supposedly, that helps with this as well. But Poly has not released that to be manipulated in the firmware to the same degree it is manipulated in the G-code, specifically Asura. Their program, Asura, will help mechanically orient or make mechanical Their program as Cura will help you make mechanically accurate prints by skipping all of this and doing it in slicer function only. I don't like relying on one slicer because sometimes the settings in another slicer are something I would prefer, and Cura is very open-ended and I can do a lot with it. So me, personally, I'd much rather use Cura and get it working right and get the printer calibrated for accuracy than solely depend on the slicer for dimensional accuracy. It's a good idea, but it kind of isolates certain aspects, individuals such as myself. In Cura, I have that setting set at 0.06. That helps solve that. Slice the circuit and test. Slice the included circuit for yourself and test. Do. Under the infill section, we need to change a few values. The first, infill density, should always be at 100%. Anything less can introduce pockets of uncured resin, which will contribute to warping, shrinkage, and resin leaking after completion. Infill pattern can be debated, but using the lines pattern is quick and effective. Using concentric is also fast, but potentially introduces lines that don't touch in a pattern that can cause prints to fail. Your print speed under the speed section is changed depending on your layer height. I will give you my settings because they work. At 50 microns, PO Poly suggests the laser speed be set at 130 millimeters a second. I have set the infill speed at a higher speed, 150 millimeters a second, to help speed up the print. That's all it does. It is unnecessary, but with the reduced line width, it doesn't cause any issues. With that, click the profile at the top and create your profile on your settings. Lastly, if you use the FEP VAT, you want to create a custom FEP profile. At this point, it's better to add a printer and name it PO Poly Moai FEP. Then click Manage Printers and go to Machine Settings. Change the measurement of the Y depth to 125 millimeters. Depending on how much the build plate is off on the plate calibration step, you might want to reduce it further. For me, I wound up with 128 on the X and 124 on the Y. It is possible I have less, but as a general rule of thumb, I do not print in the last 5 millimeters of each us. It is possible that I have less because of inappropriate calibration, but as a general rule of thumb, the last 10 to 5 millimeters on the slicer edge, I never put something there, just to make certain I don't end up with issues. You should always print large prints on the PDMS VAT anyway. Small prints should go on the FEP. There are mechanical differences between the two, but to save yourself headache and strife and wearing out on a PDMS VAT early, print small prints on the FEP. It works just fine. A lot of people don't like it and insist that it cause additional problems. Me, personally, I've had no issues swapping between PDMS and FEP. And in fact, the only reason why I do is because my prints are so large that they fail on the FEP VAT. Well, shoot, that's it. With this, you should have a calibrated printer that prints dimensionally accurate prints. Speaking of dimensionally accurate prints, this is a 100 millimeter circlet multiplied all over itself to show 100 millimeters in all three axes, including the in-between. You may think that this was the bottom. This was not the bottom. This is the side. This is the bottom. It has a little smooth spot on there, and this was the only thing that was making contact with the plate. This entire thing printed on the PDMS, of course, without any issue. I cut holes in it so that I could use the calipers to measure each one of these to make certain that they were 100 millimeters on all angles. All angles. And that is incredibly important. If all angles, all 360 degrees of your print mechanically accurate, you're doing good. Notice, I don't have this duplicate problem. That's a mess. Never bothered curing it, just so I can show that to you. Lastly, this is a 100 millimeter test file. It is 3 files in one, oriented with a calibration cube in the middle, which should read 20 millimeters in all directions. It's got a Y, it's got an X on it, so you know which direction you're facing. You'll notice that X faces the door, Y faces the tilting vat. It's got 2 100 millimeter sections here with a centimeter hash mark between each one, just so that you can take a ruler to it and verify that it is accurate, not just in the length, but on each step along the path. I had too many things in my hand. Aha! Yeah. Maybe I'll take a picture of that for you later. I just remembered. You will also want to set your first layer speed to about 50 millimeters per second and make certain that the number of slow layers is set to 1. Cura has a bad habit of way overcooking the first 3 layers to insist on maximum adhesion to the build plate. You don't need that. This was printed with 50 millimeters at 1 slow layer. Everything else did just fine. If you print with opaque resins, you might want to slow it down and or increase the number of slow layers. That's a test you'll have to do on your own. I try to stick with transparent resins because when I cure this, I want it cured through and through without any leaks. People have complained about those leaks. Anyway, this last part here is a 20 millimeter ring with a 2 millimeter wall. This can take the place of your center post test, and at my current settings there is an error right there where it didn't print completely to the build plate, but that's only in one spot. There's some fidgeting I could do. I could lower or press a little bit harder when I loosen all bolts, and I could press a little bit harder in this corner when I screw that back in to make certain that that is completely flush on the vat. That could also be a flaw in my vat or on the surface. Actually, I know that the center of my build plate is cone shaped, so these rise higher than the center. Everyone's build plate's going to have a little error built into it. All right, that's it. There are other things that I would like to change and improve on this printer. It is a phenomenally good quality printer, and it has unfortunately fallen into the wayside because of that mechanical inability to duplicate. Hopefully with this, and I have seen no other documentation on it, we can breathe some new life into this wonderful printer. Some future projects that I'd like to get into is actually increasing the build plate size, of course, for the PDMS. And under the FEP, once Moai releases the new after the 1.18 beta firmware, we're going to get Z rise between layers. Right now, I think it's set to 1 or 2 millimeters, which is incredibly low. We need it to go at least 5 millimeters or be something that we can set. All of the MSLA printers that I know of do that Z lift, and it was surprising that the Moai didn't. However, knowing that there is a PDMS layer on the Moai, it's self-explanatory why they didn't want the Z lift. Z lift will obliterate the PDMS layer. Don't use Z lift on PDMS. However, Larger FEP prints can be obtained if the Z-lift is high enough. Another thing that I'd like to improve on the Moai is galvo resolution. I remember the documentation saying that the galvo resolution was about 70 microns, which in honesty is a little low, but considering that it works on a path and is self-smoothed, that number can be a misnomer because it sets on a sliced path according to the model, not the pixel pitch of an MSLA. But I would like it to be improved, get better galvos on there. Maybe improving the galvos will help increase the dimensionality of prints, but as it is right now, they're pretty darn good. And I'd like to see how far this calibration guide takes us. Lastly, I want to redesign this. I hate this. This front panel is silly. This knob barely responds. And you know what? You probably have trouble using this knob because the knob has a proud face on the back side. Sand that down with 120 grit sandpaper for about 20 seconds. And as soon as you do that, this knob will suddenly work like a charm. But I want to redesign this entire front panel, and I want to make it something that has a thumb scroll wheel and has a broader menu manipulation. Right now, the menu manipulation is very simplistic, and turning the knobs sometimes to calibrate the Z-axis takes so long because just to get it to move 100 points takes about a minute. Other things is outside of my wish fulfillment of redesigning that front panel. I would like to see the firmware calibrate to 32-bit. I think it's written in 8-bit. I'm not 100% on that. It behaves like it was run on or calculated on 8-bit using 4 channels of logic processing on a 32-bit processor instead of a full 32-bit menu. If it is a full 32-bit menu, then the main board runs at a clock speed that is too low to handle the input value of the menu controller itself because you can overload the input. Either of those things I'd like to see improved. And if that means redesigning and releasing an entirely new controller board, I would be down for it. That would take, unfortunately, a GoFundMe. and I have been researching individuals that might help with this. Unfortunately, the way the Moai works in its very small user base, that does not seem to be a very likely avenue unless we take it on ourselves. With that said, thanks for clicking on this video again. I really appreciate it. I've got a small little channel here I'd like to see grow. Let me know what you would like me to produce next. Tell me what you would like to see me manipulate and calibrate and change or test print for you. I've been very successful, and if you have problems with your printer, let's get you up to speed and have you do results at least as good as mine. If not better, then you can tell me how you did it. Now we fade to black.